Today, we're going to have three people presenting to us, and the topic is a case study in improving security through static code analysis. That sounds like a mouthful, and actually something that I'm interested in because it's nice to have things that are automated. I love automated, and I'm curious to see what they've come up with. But we have three different people. We have Dhiren Vyas, close enough maybe, Matt Fahler, and Chris Heinemann. And they're going to talk about different aspects then of security, and they're going to give you a range of backgrounds. Now for Dhiren, he's a software developer, started off in India, and came to Houston. Actually was working for a Houston company, came over to the United States from that, and for some reason came to Springfield, go figure. He likes C++, he likes .NET. He has a wife and has a 2.5-year-old, which probably keeps him very busy. And he has actually worked at some places in the area, places like LRS, and he's worked for the state, and he's worked for Horace Mann now. So he's had some experience in the field and in this area. We also have somebody who's a little bit different in terms of background, and that's Matt. Matt came across originally as a chemist. Lee, as you know, it's like some of these people have science backgrounds. Started in classical education for chemistry and then switched over to technology, but not in computer science. He started more on the security side of things, and right now he's at Horace Mann and been there for about a year as a security architect. Now, if you remember, security doesn't always mean just computer systems. We were joking that you can secure everything, but if you forget something that's really dumb or human, your security is pretty poor. So there's a whole system aspect, and that's something that Matt cares about. He's been in the Midwest quite a bit. He's been in Madison, did that for 12 years, and just kind of worked through the ranks, and he's now a security expert, probably drives all the programmers at Horace Mann crazy with the security stuff. And then finally we have Chris Heinemann, and he's a local boy. Since 7th grade, he's been here in the Springfield area, went to school at UIS, which is a place I know, unfortunately, too well. And there's something he admitted, which I'm going to talk about. He said he likes discrete mathematics, go figure. Discrete, you know? Not calc, discrete. He also likes things like Python and Linux, which is some things I used to play with quite a bit. And ask about turtle races when you get a chance sometime. But now they're all going to be talking about this idea of security, and they're going to give different aspects of it. So, big welcome for the three at Horace Mann.
All right. As you said, I'm Matt Fahler, so I'm relatively new to the area, but you know, one other thing, I was actually born in Lincoln, just up the road, so in certain respects, it's kind of like coming home. Though honestly, I don't have any family in the area, just me and my wife and 3 kids. So I am in security, so therefore, I am the least popular person in the room. But I was the most popular security guy they could find, so they shipped me. So we want to talk a little bit about this. This is a project that we started. The original origins of this project probably several years predate me. Something they've been trying to do for a long period of time. Really working through making a lot of improvements in security and how it works in the coding. So, you know, one of the things that we're going to talk about, just kind of sum up the whole presentation in a single slide, you know, really if you're going to do something like static code analysis in any manner or form, whether it be for security, standards, whatever, you know, you want to make sure you have very clear goals and plans. You know, use some sort of industry definition. Don't just make it up on the fly. You know, give it something concrete so then your developers also have some place to go if they want to learn more. We want to talk a little bit about our results and what we've achieved, that they are possible. We have a live demo. We're going to demo a little bit about 2 critical vulnerabilities that we started with when we were explaining them to our developers. And then some of the tooling and stuff we're going to bring up at the end. So, so just to get things going, some of the goals that we had, one of the challenges that we always faced as security and developers is we don't always talk the same language. So one of the things that would happen is a developer would show up at the, as developers are apt to do, they get pushed until the 11th hour, they get through, they're waiting and waiting and waiting for UAT testing to complete, and then they go, great, their client says, I want to go live on Wednesday, so they show up at my desk on Tuesday and say, well, we need a scan. And I say, okay, we'll get you your security scan, we'll get it done today. And then I hand them back their list of to-dos, and I say, great, you can't go live till this is done. So as you can imagine, that conversation goes like all those conversations. What do you mean? What the hell am I supposed to do this? Well, I can tell you where the problem is. It's on a page. So then they're left with the unenviable task of sifting through the page and figuring out where the hell it is and what I do to fix it until they get a clean scan. So one of the things we really wanted to do was really use static code analysis as a method of providing continuous feedback to the developers, put it out of my hands and put it into the hands of the developers to be able to say, you have a tool, you can run it daily, hourly, nightly, you can run it once a week, whatever. We're going to mandate at least once a week your code has to go through the scan. But if you want to run it daily or every couple of hours, go for it if it'll help you. So it's a tool that they could run. And it would provide them the feedback so that they don't show up at my desk and go, hey, is this okay? They're going to know when they show up at my desk if their code is going to pass. And we also needed to provide management a way of measuring the improvement. If we have a tool that's always scanning and is always looking at the code base, it's a way for developers to get feedback and management to say, hey, we saw a big spike. What happened? Well, I'll tell you what happened. They dumped a bunch of new code in. They're developing some new system and they added it in Tuesday. So we had a big spike, but notice it dropped off quickly. So we wanted to give them a way to integrate this into the SDLC so it becomes consistent. So as the software development lifecycle here, you hit a gate, what has to happen? You have to get these things cleaned up in your life. You have to get these things cleaned up. Before you can go to change management, you have to have a passing scan. So it really made it just a consistent part of their day-to-day life. And really helped support standard codes across the enterprise. So we started writing standards for you have to have these types of vulnerabilities fixed, as well as in setting the stage for the really enterprise architecture teams to be able to say, these are our coding standards. So the tool has that capability as well. We really, when I first got involved with this project, I said one of the things I wanted to be really critical was picking a standard. This is the one I really lean towards. OWASP is, for anybody who does security, is very well known. They started in 2001 with really the goal of enabling companies. A lot of very big names have tied on. It is an open source project, but they are in many respects considering leading edge because they spend a lot of time looking at the industry. They spend a lot of time basically saying these are the biggest problems with code today. So they do have a site. It's really, you just go look up OWASP. You can find them real quick. They're owasp.org. They're a very good organization. They have published a top 10 list. The latest edition is 2010. There is a release candidate for 2013 that they're just about to put out. So again, the site contains a lot of good guidance. They program in everything. They have examples in Java, Python, .NET, MVC. I mean, you name it, they've probably got an example for it. So, and if they don't, they might want to talk to you about if you can write some code samples for them. But really, they're pretty well known. This was their top 10 from 2010. I could read the whole slide to you. I don't think there's much point. But to give you an idea, really, if I were to pick 4 or 5 of these, not everything on that list you'll notice is code. And there's a reason for that, because development isn't all about code. Top 1 is definitely a coding problem. Number 2 is a coding problem. Number 3 could be, but it could be how you configure your web server. It depends on how you're doing your session management. This is definitely a code problem. Chris was telling me a story about something he wrote where he's like, well, I kind of discovered I did a bad thing. And I accidentally let somebody do an upload, and it indirectly caused a major problem because I didn't check that it was a text file and somebody uploaded a picture, and it brought the system down. Whoops. So, cross-site request forgery is coding. Security misconfiguration. Could be code. Could be how your server's configured. And really, as you kind of go down the list, a lot of the things there are more and more potentially infrastructure, but can still have coding impacts because depending on how they have to reconfigure the infrastructure, you might have to change your code. So, what did we find? One of the things that we found is definite shift in people's attitude about security. Before, we were really the roadblock. You show up at my desk and I'm just going to tell you no. So, the improvements, we made a lot of improvements in the security posture, and we found that there were some really concrete examples for our most exposed applications. So our web presences made some huge strides. The teams there, I can't even say enough about the work that they've done. Attitude prior to the project, like I said, they handed over their apps, they got their test. They would say, oh, this sucks, now I got to do all this work, and I've got to go back to my client, which I said we'd go live on Wednesday and tell them it's going to be another week and a half. Last minute scrambles, they're frustrated, and as most people are apt to do, well, you made it painful, so I don't want to do it. So maybe if I call it something else, you won't think I'm doing a major release, and you'll just let me release my code to production. Really what we found is post this project, developers have really shifted into two camps. And I could say arguably, well, some have migrated to another camp, others have probably stayed where they were. Camp one, I want to say, have really embraced the knowledge. Some developers are very apt, in my mind, to be knowledge hungry. If you give them something new to learn, they're going to make better code. There are numerous stories I could tell where Dhiren was working on his own project work in addition to doing this project on the side, and he's saying, Matt, I'm getting calls from developers. They're trying to take care of additional problems that we haven't provided standards for yet. And I'm like, oh, well, that's good. He's like, yeah, but I'm not sure how to help them yet. So those are the people that really took it as a challenge, that they'd say, well, I scanned my code and there were 150 vulnerabilities. I want to get that number to 0. So, and there were also some really good people that used it and said, hey, now that you've taught me what a SQL injection looks like, now that I know what I'm looking for, I found 3 that the code system did not pick up. Said, oh, good, we'll take it back to the vendor and see what the problem is. And so they helped us work with the vendor to really improve the tool. So there are several that have gotten patches and things like that. The last quote on there is, go ahead and check my scan, it's clean. We actually had a developer say that in a meeting because he had the unenviable task of being one of the first people to be denied once this became a standard, and then after that really turned it around and said, no, 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 I challenge you to go check it, my stuff's clean. So he really kind of took it from his first denial to, I'm going to make sure you don't find anything in my scans. So second camp is, I'll do it because you made me. So the good news is they are doing it, but they're not necessarily learning anything new. They're just doing it to meet minimum standards. So like I said, the good news is they aren't finding a way around it. There isn't a way around it. You have to do it. But they're always going to ask the question, what day is that required again? So for this camp, we're left with a different strategy. We just kind of keep moving the bar. So we just keep a new minimum level every so often. So some real world results. We really since we made it a standard, we have not let anybody release to production in the last 3 to 5 months with any cross-site scripting vulnerabilities. We validate that with multiple tools, so anybody who's released to production in the last 3 to 5 months, there have been no cross-site scripting vulnerabilities. Same thing can be said of all injection vulnerabilities. So, you know, I'm sure, is there something obscure that we couldn't have caught? Absolutely, no code is perfect. I know, except for probably a couple of you gentlemen out there. You know, the developers are able to start the day. We had a developer who was one of our first people integrated with the product, who started literally started the day with over 200 vulnerabilities in one of their applications. And they took it down to, I think it was 10 to 20 really obscure, weird things in a day. So really took it to heart. And it sounds like a lot of work, and it can be, but a lot of what they discovered is in the tool, and Chris will show a little bit of this later, once you have access to a tool like this, what seems like an insurmountable task, it's like, oh my God, I've got 200 vulnerabilities, can sometimes be, if I change one line of code, I can make 50 of them go away. So, and again, we had a dramatic reduction in our internet presence findings, you know, which is the one that, for most companies, that's the one that gets scanned every year, and you got to listen to the auditors say, here's all the stuff that's wrong, and you got to get handed the list to go fix. This is actual graph. We do quarterly scans with the same type of tools that a lot of third-party vendors do. And so this is more of an external, what's commonly referred to as a binary scan. It's not a code scan. It's the one that they throw the kitchen sink at your site and say, what sticks? So this is actually a comparison of the December scan and one that just happened in April. Sure, there were 70 new findings. That can be anything. Anybody who writes code knows you introduce new stuff all the time. They cleaned up since December almost 700 vulnerabilities in their code. And there are 32 that were left. And when I say that, you got to bear in mind, some of those can be as simple as like, it doesn't agree with how you handled the errors. Okay. You know, that's more of a standards-based thing. So really not a lot left. This is the one I like, though. This was the base scan is the December scan. The one in blue is the one from April. So they got it down from 341 high findings in December down to 28 in April. So that team did tremendous work. And a year before that, they were at over 5,000. So that team, on their own, was able to just hunt and peck and find, with a lot of hard work, 4,000 of them. But this code got them down to near zero. So with that, I'm going to go ahead and turn this portion over to Dhiren, who's going to actually demonstrate the top two on the OWASP list.
My name is Dhiren Vyas, and some of you know me, and some of you may not know me. But I'm a software developer with Heinemann. I have been in this area since a while now. And at this point, I'd like to introduce one more guy. He's not here, but Mike Frederick. He has been part of this project with us, and he has great contribution to this project. So I just wanted to make sure I don't forget about that. So this is like fun part for us, a lot of .NET developers, because when Chris came here, he had this great project. He wanted to do enterprise-wide rollout of this new security tool. The problem is how you scale it to like 40 developers. So he has a vision, he has a great idea. Chris and Matt talk about, why don't we create some example, like concrete examples, show the security problem, and then we saw how to fix it in .NET environment. Because you can go online and you can find out a lot of example, but then very specific to harassment context, that was very important. So he asked us to create this demo. So me and Mike and I work on these demos. So I'll show it to you, this demo. Now, this example we decided to make it simple. So it can be applied to any project. So it can be applied to your project. Even though you are not working for Horace Mann has a wide range of projects, so it can apply in any project. But at the same time, these projects, or like these demos, are very effective. So let me go to the first slide, and we talk about SQL injection. As Matt pointed out, this is the #1 issue in the OWASP top 10. And this is how OWASP defines SQL injection. Basically, they are saying who is the threat agent. So consider anyone who can send untrusted data to system, including external, internal user, or admin. It has exploitability is very easy. Someone can just need to send the text file, command to the system, and you can exploit it. Security weakness is very common. Technical impact is very severe because we can lose the data, we can expose the personal information, private information. So accordingly, it has significant business impact because business does not like to lose the data. They don't want to know something happened to that database. So SQL injection happens when untrusted data sent to interpreter as part of command or query. Now, in this case, we are going to talk about SQL injection, but it can happen to operating system injection, or it can happen to any other external program. So let's take a look at the one example sample demo we created for our developer. So I'm going to jump into the code. So this is the ASP.NET website we created, and it can apply to ASP.NET web form as well as MVC. But for this demonstration purpose, we are going to use ASP.NET web forms because we have a lot of code in ASP.NET web forms. But once you get the concept, you can see it can apply same way to the ASP.NET MVC. Now, in this some of this demo, you'll see we are going to use like one specific example because we cannot cover all kind of scenario, but it can apply to like this problem can be manifested in various ways. So in this case, we have this simple web page where we are displaying the customer information. There's a customer ID, first name, last name, city, and state. And we are going to, when we click on the select, we are going to display the detail of this one of the customer. Just first name, last name, city. We kept it simple just to get the point. You can see here in the URL, we are passing the customer ID from the first page. Not necessarily this is the only way you are using it, but that's one of the common way. We pass the information between one page to another page. Now, if you look at the back end, I have database here also. And you can see I have one customer table, and it has this customer information. Now, I have also account table, and we have account information. Now, this account table, we are not going to display at all to this web page because it's secure. We don't want to give it to anyone's hand. So it's one of the very confidential but important table. So let me go back to our website, and I will also go into the code because it's our like working code example. So in the code, you can see basically this is the second page when there's a query string being sent, and if it is not postback, I'm going to load customer detail. And this is how customer detail, load customer detail page looks like. So we are basically capturing the query string, customer ID, and then trying to create the SQL string. So here we are creating SQL statement dynamically and then executing the SQL statement. Now, as you can see, the SQL statement has been created dynamically. So that's one of the common pattern. So what happens when I go to this page and I go to the detail page, I know that customer ID is being passed. Any developer can figure that out, and that is somehow being used in order to display the detail page. So one way to manipulate or inject the SQL injection, what I can do, and for the interest of the time, I have saved some of the query string. What I can do, I can add I can change the URL because client controls the URL. and I'm going to hit enter. Customer is not even going to figure out what happened. There's no error generated, system didn't generate error, so there's no error sent to the developer, admin. But if you go back to the main page, you notice we had all the customer from Chicago, but now everyone is from Springfield because I changed the URL, and because the developer has wrote the code that was dynamically trusting the input being sent to the query string. So what I did that I tricked the interpreter to execute the unintended command. So let's go back to database here. You can see there was a Chicago, all the customer from Chicago. Of course, that's not the case anymore. So of course, you can see that has significant impact. Now someone can do a lot worse things. I can show you one more example. So instead of just customer ID and updating the city, now I can send any kind of command. So in this case, I said, okay, go ahead and delete the account table. Now we go to the database. Well, whole account table is deleted, even though account table was not part of the UI, or it's not part of, we are not accessing any data from the web application. Now there are unlimited possibilities, they can actually take over the entire host of the application or the database server. So this is the reason, this is the number one issue, SQL injection into the OWASP top 10, and that's the reason we need to be very careful. Now, luckily, there are very easy way industries has been progressed so far. There are easy way we can fix this problem. It's just having the awareness and having this right mindset. So at the same time, I have this another function. So I'm going to comment this out, and I have this secure load customer details. So let's say, and in this case, I'm going to assume you are not using any OR mapper or any other framework which provides help to prevent this kind of problem. But let's say, or you have inherited some project and you do not have control to introduce OR mapper. So just a simple way we can fix this problem. We can go to code. It looks exactly same way. You don't need to change the pattern if you are passing the ID from one page to another page. So there are a couple of things you can do. The first mitigation you should try to perform input validation. So in this case, if it is a customer ID, you should try to validate if it is a just number only, if it is a 10-digit number, whatever your business rules are. Just go ahead and do the input validation. Now the second mitigation you can do in this case is use the parameterized query. Now all the database, whether it's SQL Server, is Oracle, they provide this support. So in this case, we are not changing significantly. We are just changing the SQL and introducing this parameter called customer ID. So now what happens, whatever information we got from the query string, we are passing into the SQL parameter. And that should take care of the problem. Now, someone try to inject additional command, it will not accept it because that's not a parameter. Or SQL will consider as a just parameter, not additional command. So let me quickly run this project because I made the modification. And let's go to the page. We still have the customer table. So I can go here, go to the detail. Now let me try to do the update again. And let's try to revert it back to Chicago and see if that works. If I go back, no, it did not work. Because if I have to change that, I have to go to database, I have to have the rights, and I have to update that table. So this is like a very good example. You can see how easily you can detect the problem and you can fix it. Now, there are many ways you can fix it. This is one of the example. One standard way, because now there are a lot of great OR mappers, entity framework, and Hibernate available. So we can use that. What they do basically is, of course, there is a still problem, but by default, whenever the SQL generated on behalf of you, it is automatically parameterized for you. So your problem is, mitigated. But it's good to know, it's good to understand that. That's how it is being fixed. We have seen the code where we are bypassing, because most of the OR mapper still allows you to bypass the default framework syntax. So you can still pass the SQL command, row SQL command, and you can still introduce this problem. So it's important to understand that how the framework fixes the problem for you. Now, some of you might be using SQL or SQL store procedure, which is also a very good way. And that way, if you have the parameterized SQL store procedure, you should not have this problem. But if you are generating the SQL statement inside store procedure, you have to be careful. You might be passing parameter, but you are dynamically creating the SQL inside the store procedure, then you have the problem. So by just using the OR mapper or by using the store procedure, you might not fix the problem. So that's why it's important to understand this problem. So that is the SQL injection problem. So let's jump into the second slide and the second issue. Second issue is the cross-site scripting attack. And this is one of the most widespread web-based security vulnerability found in this recent times. And it's called XSS because the resemblance of the name for the CSS, which is for web developer, is like a cascading style set. So it's called XSS. Some of you, if you are curious, this is how OWASP defines it. And you can find all this slide on OWASP, the link that Matt presented. And basically, again, anyone can send untrusted data to the system, can create XSS a problem to your system. It can be external user, internal user, or admin. Exploitability is the average, but someone can send just text-based input and exploit your system. It is very widespread. Some of the big name in the industry, like Yahoo and Google, has been affected by this vulnerability one time or another one. It's very easy to detect, and I'll show you one standard way how some of the tool finds out if your system has XSS issue or not. It has a moderate impact compared to the SQL injection, but at the same time, someone can hijack end users' session data. So basically, it's as good as username and password of the user for the time being of the session is alive. Someone can redirect to the unknown or unwanted site. Someone can deface your website. So we'll take a look into more detail with the code, because it's always code speaks louder than the word. And if someone tries to send untrusted data using the web application in the form of code that can be executed on the web browser, that's considered cross-site scripting. So let's take an example of this scenario. I'm going to use the same website, and I'm going to another page, and basically this is just a simple web page. We have seen that or something like that, or the part of the whole application. User is inputting some data, and we are reflecting back to the page. So in this case, I'm going to enter the name and display right back. You can see it here. Yeah. So it's just reflecting back. Now data might be coming from the database where someone else might have stored the data, but basically we are reflecting information on web page. Now one of the common way to display the XSS issue is by injecting or just a JavaScript pop-up, because there are a lot of creative ways someone can take advantage of the information. But as soon as you can pop up the JavaScript message box, you have XSS problem. So that's very industry-wide, accepted way to identify the solution. If you are going to use any runtime scanner like IBM AppScan, that's what you see in the scan report. You see a lot of the pop-ups because they are trying to say you have XSS issue. So I enter the name, we display information back to the web page. So nothing wrong, everything looks good. But now let me go ahead and change my input. I'm just going to write some small JavaScript. All right, it just says alert hi, and now let's see what happens. Oh, here you go. There's a JavaScript message box. This is not we expected. We expected whatever I enter in, display right back to the web page on the label. And if you look back the code, same way. So here, whatever input I'm getting, I'm just displaying back to the label control. Very straightforward. So what's the problem with that? Now, the problem is like similar to SQL injection, because as soon as we enter the script tag, now it become actually not just a data, now it become like executable code. And we need to protect our web application by that. Because you see the JavaScript got executed. Now someone can write creative way some code that can hijack my session cookie, which means they have my username and password while my session is alive in the system. They can redirect me to somewhere else. They can read some other information from this page and send AJAX command, and they get information in their email. So you can see the possibilities are endless. So how we can fix this problem? Again, luckily we have, once the issue is identified, there's a very easy way we can fix it. In this code I have, in the web page, you see there's enter unsafe and enter safe way. There's a 2 button. So I'll go to the code, and you can see this is where the text box was there. We are getting information and displaying right back to the label. Now the second example I just commented out, but basically says the data can be coming from anywhere. Here I'm saying get company name from database, and I'm getting the data without doing any input sanitization. I'm displaying right back to the label. So, and this is called, like they even say that they have given the name for this also, persisted XSS, because the data was persisted and then retrieved and then displayed back to the web browser. So let's fix this problem. And there are many ways you can fix it. So basically you have to encode the input you are getting before display HTML encode and display back to the web browser. There are few libraries out there, but one of the standard way to fix this problem is using the Microsoft provided anti-XSS library. It's freely available. They have like multiple version of, so it's very stable and solid product right now. So that's what we decided to use it. And basically what I'm doing, you can see in the code, I basically downloaded the library, I added the reference to my project, and I said, okay, now whenever I'm going to get the data from the text box or any other resource, I'm going to do HTML encoding. So I'm doing HTML encoding here. So I got now encoded text, and then I'm going to display back to the label. So that's it, just one change. So let's see how what happens here. So again, I have the same input, and now I'm going to use another function to execute the separate code path. Okay, you see it safely display exact same information what was inputted to the web application and displayed back to the web browser. It did not executed any code. So this is the example of one of the example of HTML encoding. Now there are, because web is complicated, there are a lot of things going on. There's a XML part of the web, there's a URL part of the web, there's a JavaScript. Luckily for all these different input and all this execution environment, anti-XSS library has provided software and solution. So I have included some other example. So if you are planning to dynamically create a HTML attribute rather than the data to the element, you can use the attribute encode. So you got your input from end user or from database, make sure to encode from the attribute. Same way URL, if you are trying to manipulate URL, you got the, you ask user to enter the search term, you're trying to create the URL with the that input, and you're basically manipulating the URL, make sure to use the URL encoded function. And it's pretty obvious once you look at the anti-XSS library. JavaScript, big thing. A lot of people writing a lot of application with a lot of JavaScript. Make sure to encode the JavaScript data. Whenever you are getting data, it's okay to use the data, but make sure to encode in JavaScript. Do not use HTML encoding in this case. Encode JavaScript and use it inside your JavaScript. Your JavaScript is fine. And the last one is that XML encode. Now, there's one more example. Here, I do not have example here, but in some case, you have really good reason to use the HTML. So you need your angle brackets and everything. And you have to be very conservative about using this approach. You have to have really good reason to accept the HTML from the user. But then in that case, you have sanitizer. That's another namespace you'll find in anti-access library. And use get safe HTML fragment method. And you can safely get your HTML data. So this is the approaches we took to mitigate this problem. And I think it worked out really well. Most of our common problem, it has been fixed from developer who just started their career to the developer who has been very experienced in the software development. So I think our demo worked out really well also for end user, and actually in this case our developer, and they were able to provide really good result. So with that note, I'm going to go to the next session, and the next session will be for, okay.
Can I just see that line of code for the text again?
Sure. Let's go back to the code. And you want to see where we are using the text box and displaying back to the label?
Microsoft.security.application. I didn't code where that is.
Oh, okay. This guy right here?
And there are parallels for all the other versions. Yeah.
Anyone else has any question? We can also, after Chris' presentation, we can do some quick QA as well, but feel free to ask if you have a question. Okay, so I'll hand it over to Chris.
So I kind of got handed this project in October of last year. A purchase decision was made. They said, hey, implement this thing. And I was blessed to have Mike and Dhiren and Matt, because they honestly did all the work. All I did was put together this pretty little chart that said how we were going to do it. We implemented it in 2 stages. The first stage was XSS and injection, which you just saw the examples of. That was done in April. Then just honestly, earlier this week, we implemented stage 2, which got rid of all the highs and the mediums, or just the highs?
I'd say it's most of the highs.
Most of the highs. But anyway.
It's all the highs, none of the.
Anyway, we upped the bar, and we have plans to up it until the security guys get comfortable enough to stop. Which will probably be never. Anyway, so tooling can help. It was amazing, like Matt was saying earlier, security's been trying to get the developers to, believe in this whole security testing thing for like several years, and the developers keep saying, yeah, we're gonna do whatever, just the minimum. This tool came in, and it really gave them the ability to see what was wrong and find it quickly. So we landed on a tool called Checkmarks. There are several others in the industry listed here. There are some open source ones, but we didn't want to inundate people with a whole bunch of stuff, because we're not here selling anything. We're just telling you what we did. So remember, there were 2 key goals. One was to get the developers information at their fingertips, and the other was to get management feedback and measurements on improvement. So I picked here a project, and I picked it because it's got a nice pretty chart. Management types like that. But as you can see, the first scan on February 12th was over there in the orange, which would have had 47 highs and 21 mediums, or I guess 21 highs and 47 mediums, sorry. And then over the course of about 2 weeks, they dropped it down to no highs and 44 mediums. So this is the same project. This is inside the tool. So once you're in that project, you say, okay, now show me the actual vulnerabilities, not just the pretty graph. Over here, it shows you the various different types of issues that it found. So reflected XSS, all clients, so that's basically the XSS that you saw, it gets reflected back from input. So it's the very common one that people see. There were 21 of them. This gives you the list, just like Visual Studio debugging. And this is the source code. So the tool pulls the code from TFS. It does an analysis of it, and then when it finds a vulnerability, it basically creates an item, and then it can take you directly to the line of code. So selected value is exactly the same as the label or the text box input, the text field. So you can do the same cross-site scripting with it. Now notice that there are 21 of them, and it's on selected value. So another tab in the tool is this graph. So that the other one was results, this one's the graph. This shows you all the code paths that have that same problem. So the 21 can be fixed at one line of code because all the selected values come down to that DMC, whatever that DMC is. If you look up at the top, it's a method, get plan provision data, and they pass in a string. So if we take that string and sanitize it, we're good to go. We don't have to change it in 21 places, we can change it in one place. So this isn't really exciting, but I wanted to show the reporting capabilities. This is a different project, but you'll notice that it's a pivot table basically like you do in Excel. It gives you the numbers. In this project, it's important to note that the numbers went up on 5/23. It also gives you a nice pretty graph. So you can see that on 5/23, it shot up, management's hair goes on fire, they're yelling and screaming, why'd it go bad? Well, that's probably because somebody checked in a new subsystem or a new interface or something and it just hadn't been in the environment yet. And then 7 days later, they have it drop back down. So did I actually get done in 10 minutes? I went fast, dude. So just to reiterate, if you plan to go down one of these paths, make sure you have clear goals, collaborate, use industry terms, don't make up your own because you're going to confuse people. And if you use industry terms, people can do their own research. We did have some very dramatic results, especially when we introduced the static code analysis tool, because people could see exactly where they went. Dhiren demonstrated how the vulnerabilities work. It's amazing how much you take for granted just that you trust the user, and then if all of a sudden you can't trust the user. And tooling can help. Are there questions?
I've got a couple.
Figures.
One of the claims for Entity Framework is now all of a sudden you don't have to worry about injection attacks. It's gone. Are there vulnerabilities that you know about? Because I said, well, first of all, are you using like Entity Framework or in Hibernate as an ORM on any of your projects? And are there any vulnerabilities that have been flagged?
Okay, so there are two things to note there. Entity Framework under the covers uses prepared statements,
Right.
so it does prevent most of the problems. There are two things you need to watch out for. One is if somebody bypasses EF, so you just can't trust it, you got to do your code reviews. The other thing that we found in our environment was it's called second order SQL injection. And it's weird because one SQL statement executes and the results of that are used in the second SQL statement, and that actually caused a problem. And that was part of EF, how the EF generated its source code. Honestly, we haven't figured out how to fix it yet, but it's still there.
Okay, so it's probably in the code generation sometime down.
Yeah.
Is a security answer to your question?
Again, I never trust
no,
magic
no.
bullets, but the thing is, there is a general improvement. I was just wondering things
absolutely.
to watch out for.
One of the things that we've been really excited to see is, like you said, these frameworks being built because they're tools available to developers. You're no longer left writing your own solutions to the problems. So from that perspective, I'm very positive of the frameworks from the perspective of they're a standard, you can set a standard. We're using the entity framework to solve this, or we're gonna use the Microsoft anti-XSS. And from that perspective, you can set very clear standards for all the developers to follow. But like all code, every single one of I'm pretty sure most of the frameworks I've come across have periodic security vulnerabilities inherent in them. So that's why you have to be careful about making sure that you are periodically updating your frameworks in all of your applications, because I know they've released multiple releases of several of the Microsoft libraries, and some of them have been patched even as part of like their Patch Tuesday, because somebody made a coding slip in one of the lines and there was a problem, and technically there might be some weird obscure problem, but there's a security vulnerability in the library itself. So, from that perspective,
Always have to be careful.
You always have to be careful, and you can't just like download it once and then just assume it's safe. You have to go out and make sure you're getting the latest version of that library, make sure that you're reading where there might be problems periodically.
Okay. Another thing is, do you have a habit of using things like GUIDs? Because anytime there's keys that are integers, they're guessable, very easily guessable. So is that one of the strategies you tend to use?
Yeah. A lot of our newer systems, we've gone to using GUIDs, especially there's a vulnerability with playback of URLs. So if your application is kind of session agnostic and it just kind of always works off posting or the URL, you become vulnerable to somebody replaying what they recorded and then just basically changing a couple variables. The way that they recommend fixing that is by making each URL unique. Attaching a GUID is the most common way to fix that.
Okay. The other thing that we've been running across is we've been working with like Windows Identity Foundation, and it seems like that's a different method for security. Is there anything from a security standpoint in doing that compared to the old WinForms kind of approach? Because that's been pervasive for years and years. In other words, do you ever use like the current forms authentication, or are you changing over to the identity framework?
We've been researching the identity framework. I think that identity framework is fine. I think there's some very kludgy things with the way that Microsoft has implemented it. There's much more elegant ways to do it, and there's plenty of third parties out there that, while we're loath to integrate with somebody, look, why are we recreating the wheel again? But there's also something to be said for, hey, we're a .NET shop and we're running Microsoft all the way across the board. Why do we need somebody like a CA or an Oracle or some other third-party single sign-on plugin to do this? But I'm just not sure Microsoft's gotten there yet. It's like their generation, they're just not quite as mature, I think, as some of the other products, because the integration we attempted was just it got very complex real quick, and I thought that wasn't quite what the development needed. And there's lots of ways to extract the whole authentication and authorization process to be completely independent of the code while still being completely secure. So,
Well, that's what we're right now trying to do. We're trying to move the application completely away from security and then have kind of an interface between the two that you can trust.
Well, we looked down using claims-based.
Right, which is what I'm talking about.
Yeah, and honestly, what we found is that we didn't need the STS and all the plumbing that came with it. For our applications, most of the time it was the application had a set of permissions, and then you needed to basically assign those permissions to users or groups. And so we externalized that part, and so the application could just say, okay, Windows authentication, give me the username. I'm going to call this web service and say, give me all their permissions. And it gives me the setback, and I basically just cross-reference the two. And so it made it, honestly, easier for us to just do it as a horseman component than to mess with all the plumbing.
Right, well, now the plumbing's a little better if you're using Net 4.5, because it's actually baked in the framework. Before,
Okay.
it was a lot less comfortable. one of the things is for cross-site scripting, we've had a lot of people that try and use JSON-P deliberately. Do you have any opinions on that? In other words, just to try and get cross-site and make it really, really flexible. But from a security standpoint now, you're starting to have things wide open.
Yeah, we have one project that they wanted to be very, they have a beautifully, very interactive application now. But we don't have a lot of JavaScript expertise. We don't have a lot of people that have dabbled much beyond MVC or the out-of-box ASP.NET. So that project had to do a lot of justification of support.
Okay, well, for example, we're teasing with the idea, do you go to SPA or not? And it turns out there, cross-site scripting issues and having huge persistence and long-term persistence in the client
Right.
becomes a very different paradigm. And that's one of the concerns that's still there that has to be addressed.
Right. So what we ended up getting to was letting the project go forward. They had to work pretty heavily with this tool. We actually had some stuff we had to send back to the vendor. The one thing that was very interesting is they were entertaining going spa, but the hot tub was just too warm.
Okay.
No, it actually they found that from a support standpoint, they couldn't get multiple developers in there, and so they ended up breaking it into multiple pages.
Okay.
I honestly, we haven't come up with the best practice, but I honestly think we're going to see more of it than what we have.
It will probably become more important as you start seeing richer client side and you want to have more persistence put on the client.
Yeah.
But I've seen the same thing. From a security standpoint, really where you end up going is this is a very common problem. My previous company that I came back from a year ago, they went very heavy down that line. They're a hardcore Java shop, and they were using anything from FlexFlash to heavy Java to, oh God, what all were they using? But they were making the client like interface just super rich. You know, like it did all sorts of fun sliding and moving and in the client calculations and stuff, and really the model doesn't change. They're putting more trust in the client, but when the data comes back in, all the same rules apply. It's basically never trust anything, even from your own code. I mean, it's the same validation process, same type of stuff. You're putting yourself more at risk for what's wrong with their browser than what's going on in your code. So you have to triple check when it comes back in. So
Right, so it's the same server-side types of checks.
it's the same
just a
server-side
different
types of
experience.
checks. Basically, the simple rule of thumb from a security perspective is never trust anything and always validate it on the server side, never validate it on the client side. I mean, I've seen them done with client-side validation, but it's always double-checked on the server side, because so many times we want to create a cool, rich application with, like, say, hey, you type in this stuff in the text box and I want the screen to maybe go red if you've typed something wrong, so that you don't like hit submit and then you go, oh, now I gotta click what? You know, and now that, you know, I want to just make the cool text boxes that tell you when you entered something wrong right away. But on the server side, I shouldn't assume that data's right when it comes to me, even though I did cool stuff in the client.
Correct. Well, I've had an application we just finished up a while ago that they wanted all those cool nifty things, and there's a bit of a cost. Okay, I've hijacked the questions. Anybody else have some?
Yeah. Oh, okay. It seems that when you hear about security issues in the mainstream media, right? They're always about, usernames and passwords leaked or credit card details leaked, right? And a lot of times that is because of lack of physical security, okay? Someone breaks into a server farm and steals a hard drive or steals a backup tape off a truck or whatever, right? And it amazes me that this keeps happening and happening and happening when this has been a solved problem for decades. right? Because it's not the issue that the hard drive was stolen or that the backup tape was stolen. The issue is that that thing happens, and then the company has to come out and admit, well, you know what, we stored the credit card details in the clear, or we stored passwords in the clear, or we stored them encrypted, which is basically the same thing. It's like no one's ever heard of salting or hashing. Why do developers keep making these same mistakes over and over again? These are all solved issues where you can mitigate the results of, physical security breaches.
I think there's a couple things there. That's a very good point. From my perspective, a lot of it is education. Look, things like OWASP didn't even exist until 2001. So in some cases, we've got developers, people have code bases. It's very common where we are. A lot of people have code bases that are based off stuff that was written in the 1970s. Even stuff that's built in .NET. It's like, well, some of this stuff was started in C, and then we kind of morphed it into this, and then .NET came out, and we kind of dabbled in that. And so some of these are developers that predate some of these problems that you're right have been solved for over a decade. There's a lot of education. It's been my experience that not necessarily a lot of even new developers, they're coming out of college and they haven't been trained on this stuff. They're making these common problems. And I think that's where some of these organizations like OWASP are trying to spread the knowledge, because that's one of the struggles I've always had, and that's why I've loved this project, was because it's about empowering the developers with the knowledge they need to not make these mistakes, to learn the best practices, like, hey, you should be hashing passwords and salting them. You shouldn't just be encrypting them, or those types of problems. The problems have been solved for a long time. The problem is the knowledge has not been shared readily. It's not been made a part of everybody's life. And these things come at a cost. So some companies are like, no, I just want it in. So at the end of the day, there are some decisions that are just made on a management level that says, we don't care. And that's just life. And they don't care until it's their name that says, well, LinkedIn used just hashed passwords. We didn't even salt them, and I had to reset the passwords of 20 million people. That's some of them are very, I'm pretty sure LinkedIn was not a stolen hard drive. That one was a SQL injection vulnerability. But that's it. Some of them are things like cross-site scripting. Some of them are SQL. There's very common hard drives that get removed. You're right, that's a very common one too.
The other one is companies that salt and hash the passwords, but don't salt and hash the credit card numbers of the customers. To me, that's just such a head smacker. Why would you do one and not the other?
Yeah, that's just, again.
Why would you store the credit card number at all?
There's a lot of companies, though, that are making very common decisions, knowledge decisions to not meet PCI compliance. That's just a decision. PCI is not mandated by any federal agency. There's, the biggest problem and challenge is the risk that, can I take the fines, or is Visa really going to tell me they're not going to accept my money? So, it's a little bit about enforcement and whether they get caught. I hate to say it, but that's a business risk. Organizations have been taking for decades. It's no different than the ones that say, well, I'm going to dump stuff in the Mississippi River. If I get caught, I guess I'll pay the fine, but if I don't,
The other big thing about the things you see in the media, they don't tell you about the ones that got thwarted. They don't tell you about the lost hard drive that was fully encrypted and nobody could ever get anything off of it. But what I do find funny is they do tell you about when the FBI can't unencrypt a hard drive. I find that interesting. But so I think that security is getting there. I know that Horace Mann has really been taking it seriously, and I know I've been hearing more and more from my peers that they're getting it, that the companies are getting it. It's just I agree. It's a matter of education.
it's a matter of education, and like I said, the biggest challenge I think is just the length of time that we've been on old code bases. I mean, God, I mean, do we even want to guess how old the code base is for the state? I mean, they've probably got stuff layered on from the 70s that's, you know, I mean, or earlier, you know, and it's just a challenge that a lot of organizations have. I mean, how many organizations have old legacy mainframes that they're still dealing with, and has anybody looked at that stuff in decades, and how are you going to sort through the, you know, 40 plus years of layered on code to figure out the problems?
When we rolled this out to the Horseman development community, several mainframers came because they're very intrigued by what the new world can bring, and they're trying to make the migration. And one of the developers said, you know, now that I see that, I understand why this rec script I have keeps breaking. And his rec script actually had a SQL injection bug. And he's like, now I know how to fix it. So anyway. Anybody else?
This question's for you. At the beginning, you were showing I don't know if it was a tool, but it was evaluating code if there was errors and stuff. Is there a free tool for that?
I'm sure there are some free tools. OWASP, actually the OWASP site would be a great site to go check for that. I know that there are some integrated with like some products, and there are a few scanners that you can use, but the one that I was using was IBM Rational App Scan, not the Source Edition, just their IBM Rational App Scan. A lot of other people have used like Qualys and others. What?
IBM what?
Rational App Scan.
Is that free?
No, that's a price. Most of the really good ones are gonna cost something, but I think there's a couple that are probably freeware developed, but I don't know how solid any of them are. Yeah, I've never had, no offense, but I've never had much faith in the Microsoft versions.
For all the .NET developer, I think there's a Troy Hunt. He's the actually MVP for ASP.NET security. He has a great website. There are some basic security check available, as well as he has about like one ebook totally free, and it targets exactly like OWASP top 10. You know, he talks same language as a Matt. So how to fix this in ASP.NET? Troy Hunt, he's like MVP, and he has a website. You will find a lot of good resources. Yep.
Okay, real quick on the end, how much do these commercial tools cost? Are they like 10,000, 50,000, 500, 100,000?
The question, so I know you were kind of leaning the mic out there, was how much do some of the commercial tools cost? The short version is anywhere in that range, and the range you gave was like 10, 20, 50, hundreds of thousands of dollars. Some of the scanners, it really kind of depends on how you license it. You can get just standalone versions, and I mean like standalone, like you can install it on one laptop and you can scan any number of sites, but you know, that's probably your least expensive version. To like, they have like full bore server ones, and they'll like spider out and do all sorts of funky things. It really just kind of depends. Like I don't even remember what check marks cost, but I know like some of the code scanners are over $100 grand. Because I know my previous company was implementing, I want to say HP's Fortify is what it's called, and they spent easily over $100 grand for that. But they were buying like the full server version with like the equivalent of TFS, and you check your code in and it automatically kicks out reports. And this will do similar, but it's integrated. It was considerably cheaper. I don't know what they paid, but I think it was all paid for before I even saw it.
Yeah, I never saw the.
I didn't see the bill, but I'm sure it wasn't cheap. It's not like hundreds, it's in the thousands for sure,
Yeah.
most likely 10,000s.
I have a question. So when it comes to scanning your applications, whether it's scanning code in these code analysis tools, or coding, or scanning something that's like a running application, how often do you find yourselves running into false positives, and what's your method for dealing with those?
I found, it depends on the method of scan. I found the code scanners to be a heck of a lot more accurate because they're checking the actual source code at a very minute level. I haven't found as many false positives in that space, at least with this tool yet. I'm sure we'll come across them. Because in most cases, the developers are like, oh, well, I can still fix it, and I know how to fix it. And so even if it wasn't officially broken, well, they fixed it even if it wasn't. So I find it more of a problem in what we refer to as a binary scanner, which is like what the IBM Rational app scan is, not the source edition. Because it's not testing your code from that perspective. It's saying, I pointed at a web page, and it goes, okay, what elements are on this web page? I have text boxes, I have submit forms, I have, all these elements, and then it goes, okay, well, I'm gonna test these for cross-site scripting, and it starts pitching all sorts of stuff at it. And in those, you get a lot more potentially false positives, just because every once in a while it'll be like, I think there's a SQL error string popping up on the page, because it finds the words SQL and a number after it. It's like, well, that's nice, but there's a random string of characters. It was bound to come into the letters SQL and a number. So I see more, there's a lot more cleanup in those types of scans that I've found that have to be done than in these. These tend to be more like, code scanners tend to be a little cleaner from that perspective, but they still are gonna give you things like, one of the ones that pops up is called a privacy violation. And it is an issue, but it's also more of a company issue. It's more of a political, what do we want to do from a coding standards issue than it is a like hardcore security vulnerability. It's more just pointing out something that could be a problem. So
When we put this in, we had, initially, through the education, there was a lot of people saying, I think this is a false positive. I think it's a false positive. And it really just turned out to be education. It was more like, it really is a vulnerability, and let me show you how it's a vulnerability. When I talked about the second order SQL injection one, that was one that stumped all of us. And so
we had to research.
We had to research that one. But we've had several people report false positives, but nobody actually having one. So.
Again, getting back to the scanning, code scanning. Do you guys use a continuous integration process? And if so, do you guys include this as part of your build process? And
So if Mark Schiffer was here, he would make sure that I pointed out the check marks is slow. So we do check marks is done on a nightly schedule. We do build on check-in, so we have gated check-ins, but this is not integrated with it because the developer's not going to want to sit there for 2 hours.
well, I'm not saying I'm not saying to run it every time you hit F5. Okay, that's not what I mean. I mean as part of the CI process. And I mean before you deploy, do you make sure that the scan runs every time you hit the build server? You know what I mean? When you're building the project in order to deploy it or test it.
We're looking at integrating with the build. Right now, they are two separate efforts. So Checkmarks is scheduled, basically every project we have is scheduled on a night of the week. So it's once a week. But our end goal is that whenever somebody checks in or tries to promote code to QA, that at that build, it has to go through here.
Right.
As an example, the time frame though, when you...
Because that would have avoided that big spike issue that you had, right?
Right. Yeah, because effectively somebody had their code base over here and they had it checked out for weeks or something while they're making all these changes.
Sure.
The check marks on a medium-sized project, and I know I don't have any frame of reference because we've all had different backgrounds, but what we would consider a medium system takes about 2 to 3 hours to scan, compile the list, generate the report. So it's significantly slower with VB.NET than C#, which is kind of interesting. But, so
It's telling us all to program in C#.
I mean, that's just part of the evolution. I mean, would we like to get there? Absolutely. But it's just one of those, for now, we're pretty happy with where we're at. They're required to show us which scan. So basically, they have there's a change management process currently where we're at. And the requirement is you have to get sign off from enterprise architecture prior to going to production. Well, one of their checks is they show up at the changelog meeting, the developer shows up, and then they say, okay, I've looked at their latest scan, they're clean, or nope, they're not clean, they can't go up. So, you know, there's always gonna be spikes, especially like I said, I mean, development of code, you're gonna miss stuff. The hope is that over time it goes down more than it goes up, but, you know, and most of the projects we've seen have made significant improvements too. I mean, some of them were very clean to begin with, but others were like just massive code bases that had been built for over a decade, and they were like, you know, here, have 1,500 vulnerabilities, and they've made huge strides since then. But you know, we know that they're hunting them. It just takes time. So
one thing I like to point out, and that goes back to your question about why we still find the problem, you know. And there are multiple issues, I think, like developers and the management and, you know, how it's rolled out. And one thing I like to point out in this project I've been part of, and I told Chris and Matt they did very good job, you know, making sure like they are along with developers. It's not that they are against each other. Chris is leaving, so I have no benefit saying good thing about him, but he made sure that, so we showed them example, we gave the tool, right tool, and one big decision we made was, so should just lead developer has the tool or access, or everyone? And I remember both of them said everyone. It's not just lead developer. I think that has big impact, you know, and some of our like junior developer, like they spend more time, you know, they work harder than other people.
yeah. And different people get different mileage out of the tool. I mean, some people are just leveraging the once a week scan. I know there are other people that have checked in their code, and they have like dozens of scans because they're checking it in every hour or, you know, whatever. But those are the people written in C#, and they, you know, their code takes 15 minutes to run. But, you know, it just depends on which mode they're in. Some of the development teams are in very heavy, we're just gonna wipe everything out. So they've got like 1 or 2 people dedicated to just going in and cleaning up the code base, and that's what they're doing, so.
Also, this tool is like probably Matt didn't get enough time, otherwise he can talk more about static code analysis, which is very cool because you can upload one file, just one class out of whole your web application, and it will find the problem for you because it knows which project you are running. So it's ASP.NET or MVC and what kind of problem it is, and just one file. So if someone says, oh, review I have 10 problem and I need information about this 10, ignore other 100, I can take those files and just run those, and it works because it does not care it compiles or build, and you can do on demand. You can zip it or upload it, and it works.
Any more questions? Thank you very much.
thank you, everybody.
Thank you.